In this session, we will learn about alkenes. Okay, alkenes, about the general formula and about the mechanism of reactions, and then types of reactions of alkenes. Okay, and then describe the difficulty of the disposal of polyalkenes. Okay, let's start with the general formula of alkenes. The general formula is CnH2n. So the smallest alkene is ethene. Yeah, since it needs to make a double bond between C and C, so the smallest alkene is ethene, C2S4. Since the double bond present here, it is called unsaturated hydrocarbons. Okay, this is about the general formula. How to form alkene? Later on, you will see that many reactions that can use to form alkene. Yeah, but in the reality, yeah, cracking, yeah, is the most useful process to form alkene. Since crude oil contains a very large hydrocarbons, very long chain hydrocarbons, and it is not useful. Yeah, so we can crack the long hydrocarbon to form a more useful compounds. Okay, this is can be done, yeah, by using a high temperature and pressure, or high temperature and pressure, yeah. Okay, this is the first way, yeah, to crack the hydrocarbon. Okay, and then the second way is by pass over catalyst and use heat. Okay, this is the second way. So high temperature pressure and high temperature and catalyst. You can see that a very large hydrocarbon C10, yeah, could be bricked to form hexane and butene. Okay, means how to separate this? Why 6 and 4? Can it 8 and 2, for example? Yes, it can. It can be, yeah. So the mixtures of product usually form. Okay, but if you want to specific, you need to use a catalyst. The Ziegler-Natta catalyst can be used to cracking in the cracking process. But we will not discuss about that. Okay, let's try to answer this. Okay, have you tried? Two different conditions under which long chain hydrocarbons may be cracked. First is high temperature and pressure. Second is high temperature and catalyst. Dodecane is a long chain hydrocarbon which is present in crude oil, may be cracked to form butene and alkene. Write a balance equation for this reaction. So we have C12H26, crack to form butene. So C4H8, right? What the rest of alkene then? 12 minus 4. So C8, yeah? C8 is 18. This is the alkene. Okay? Or sometimes you can also produce two alkene molecule, right? 2C4S8, yeah, since the number of carbons still 8. Yeah, so it's still okay, yeah. And the rest is C4S10. This is also alkene, right? Butene. So it can be this or this. Okay, let's discuss about reactions of alkenes. Alkenes has double bonds, so it is more reactive compared than alkene. The types of reactions of alkenes are addition. This is a very famous reactions of alkenes. And then oxidation, also the polymerization. Let's start with addition reaction. You can see here that addition reactions of alkene can produce many products. Yeah, it can change to many other functional groups. Let's say this first one. Okay, let's say this is the first reaction. Okay, alkene with hydrogen with nickel catalyst. Yeah, this means the reduction process. Yeah, or addition of hydrogen. This changes alkene to alkene. Number two, addition of water in the presence of concentrated H2SO4 as catalyst change alkene to alcohol. If you use HCl, halogenoalkane will be produced. If you use Br2, dihalogenalkane will be produced. And if you add alkene with alkene, the addition polymerization will be occur. So this is the main types reactions of alkene. Why alkene is more reactive? This is due to the double bond. Okay, you know that double bonds, that means the p orbital present, and the pi bonds present. And then you know that carbon in alkene has sp2 hybridization, right? sp2 hybridization has 120 bond angle, and this is a fairly open structure. Okay, so this is open. Why it is said open? You know that, yeah, this is planar, right? So the reactants can attack from above or from below. Okay, so this is that's why it is called that it is an open structures that easy for incoming groups to attack. Okay, the pi bond represents an area of electron density above and below the plane. Okay, because electrons in the pi bond are less closely associated with the nuclei, it is a weaker bond, yeah, than the sigma bond and can break more easily. Okay, so the pi bond can break more easily compared to the sigma. Okay, and then this is the last statement here in this page. Because it is an area of electron density, the pi bond is attractive to electrophile. You know, electrophile is an electron seeking species, electron deficient species. So later on, the very high electron density on alkene will attack electrophile. Okay. So how to make the mechanism reactions of electrophilic additions of alkene? So once again, it is called as electrophilic addition. Why it is called electrophilic addition? Because the double bond attack electrophile. Okay, this is very interesting, yeah, because in this slide you can see that double bond attack Br2, right? One Br from the Br2 molecule. Actually, Br2 molecule is a non-polar compound, right? Since the electronegativity of Br and Br cancel out each other, so this is non-polar. Okay, but because of a very high electron density of carbon-carbon double bond, it can polarize the closest Br atom, yeah, the nearest Br atom, and tend to repel electron, yeah, this bonding electron will be repelled towards the another bromine. Okay, once again, the electron density of pi bond here, yeah, the pi bond here, will polarize, yeah, the closest Br atom, so it will have the positive partial charge. Why? Because the electrons in the bonding electrons here will be tend to repel towards another Br. So another Br will have negative partial charge. Okay, so This makes, once again, the Br has partially positive charge and can attack by this electron density very, very easy. For all students that learn about organic chemistry, please remember that in organic reactions mechanism, the electrons always attack the positive region, not the opposite. Yeah, the positive region cannot attack the negative. Only the negative that attack the positive. So please remember, you should always draw curly arrow from negative region to positive. Negative to positive. I always say like this, yeah, and I give pressure to my words because this is very important. Okay, so that's why the arrow from double bond to Br. Look here, not from Br to double bond. Okay, this is we call as reaction mechanism. Okay, so once again, this attack Br, so the process Br, and since it is attacked by double bond and make a new bond with the C, heterolytic fission will be occur, yeah, in Br2. So that's why the next after the heterolytic fission, okay, I will use the purple one here. The purple Br will has negative charge. This is iron. You know the heterolytic fission from iron, right? How about the Br that attacked by the C double bond? It will make a new bond with the C. Yeah. In this case, this Br, yeah, already make bond with C. Okay. This is we call asymmetrical alkene. Yeah, symmetric. Why this is symmetrical? Since this carbon bonded to two hydrogen, this carbon also bonded to two hydrogen. So symmetric. So Br can make a bond, yeah, to this C or to this C. Same. Okay. Let's say it it makes a new bond with this Br, with this C. Yeah. So make this, and then since the double bond break, then the next C only has three bonds, right? One, two, three. So this will have positive charge called as carbocation. This is the intermediate. Yeah, the intermediate for electrophilic addition reaction. Next, the Br minus. Yeah, the lone pairs of Br minus attack the C positive. Once again, I already told you that the arrow should be comes from a negative region. Yeah, which is the electron position. So you can see this electron attack positive. Make a new bond to form 1,2 dibromo 18. Okay, is it difficult or is it simple? Okay, some students find this is very difficult. So everyone, now let's try to make the electrophilic addition mechanism. Yeah, using this whiteboard. Electrophilic addition. So let's say we have 18, yeah, just now 18, CS2, CS2, 2 bromine. What you should do first, make the curly arrow, yeah, from the lone pair, from the double bond to the closest Br. Now forget the partial positive and negative charge. Okay, since double bond polarized this Br, heterolytic fission occur. Okay, do you still remember what's the product then? Yeah, one Br will make a new bond with the C. Yeah, since this is symmetrical alkene, you can choose any other C. So let's say I make this. So this CH2 has positively charged. Yeah. And then this will give you Br minus as the product, right? Since they had division always form cation and anion. Then the Br minus from the lone pair, please give arrow from the lone pair to the carbon, yeah, to the carbon. So the product is okay like this. Okay, understand? The question is how if it is unsymmetrical alkene? Okay, let's say if we have propene. How if I have propene? CH2, yeah, CH2, CH2, CH3. Again, attack Br. But now the problem is which carbon, yeah, should make a new bond with Br. There are two possibilities, right? So for example, Br make a new bond with the first C. This is called as a first C. This is the second. This is the third. Yeah. So this produce this CS2 Br CS2 CS3. So the positive charge will be right here. Okay. And the second one, if Br attached to the second C, CS2 positive here, and then CH2Br, and then CS3. The question is, which carbocation is preferable to occur? Look, I already told you about carbocation and how it is stabilized by positive inductive effect. Okay, this is the major carbocation. Why? Because this carbocation is secondary carbocation. Yeah, this carbon, this positive carbon, has two R groups, which is this C and this C. Help to stabilize this its positive charge. While in the second one, this is primary carbocation because it just only have R group to stabilize this positive ion. The rest is hydrogen, right? So this is minor. So the product would be CS2Br, CS2Br, yeah, CS3. Yeah, although the product will be same, yeah, the product will be same, okay, but this is the major carbocation that will be produced during this reaction. Okay, the most complicated one will be occur in addition of hydrogen bromide or hydrogen chloride. Later on, we will discuss about this. Yeah. So all done with electrophilic addition mechanism. Okay, let's practice. Okay, how to answer this? Why alkenes undergo electrophilic addition reaction? Okay, since alkene has double bond, which is an electron dense region. So it is susceptible to attack by electrophiles. Okay, Outline the mechanism of the reactions between wood to in with bromine. Yeah, outline mechanism. That means every time you see the words mechanism, that means you should throw the curly arrow. Yeah, to show how the electrons move. Okay, don't forget the partial positive and negative charge always. If not, the point will be reduced. Okay, and then this will be produce the carbocation. Yeah, will be like this. Don't forget heterolytic fission. Form Br anion. Okay, this will attack this. Okay, and this will produce the product. Okay, name the product. Outline the mechanism and name the product. The name is 2,3 dibromo butane. Yeah, halogen alkene. If you forget about how to naming halogen alkene, you can rewatch the previous video. Okay, draw the mechanism for the reactions between ethene and chlorine. So this is same, yeah, exactly same like just now, ethene and chlorine. Okay, to form 1,2-dichloroethene. Yeah, so same. So we are done with the first session, and the second session we will learn about the second video of this chapter. We will learn about uh, the types of addition reactions. Okay, this is hydrogenation, hydration, blah blah blah. See you again in the next video. Bye bye.